Good evening. Join me once more as we step into this calm space for a deeper look at the workings of the universe. With a breath, we leave the now. Tonight, our journey takes us deep into the heart of the first Exodus, a strange landscape governed by different rules. The deepest truth, perhaps, is that the cosmic clock always runs fast for one who sleeps and slow for one who waits. Tonight, we begin not with a discovery, but with a calm intrusion, a quiet disturbance in the fabric of what we thought we knew. Imagine, if you will, the sheer volume of history, measured not in the flimsy millennia of human records, but in the 4.5 billion years that this blue marble has been turning, a silent, swirling testament to endurance. For most of that time, our planet simply was an endless, churning laboratory of geology and deep-sea chemistry, long before anything that walked or thought had the impertinence to name it. We stand now, in the year 2025, with our powerful new eyes and ears pointed toward the velvet dark, listening for the whispers of the universe. And yet, we often forget to look down, to listen to the echoes beneath our own 7 feet of topsoil. There is a subtle, unsettling fact about our earliest history, the fossil record. That great, rambling diary of the planet is not merely incomplete. It contains gaps of staggering silence, abrupt transitions, and sudden, inexplicable appearances. The sheer improbability of life arising just one time is a miracle. But what if the more curious paradox is the missing 20 million years between the emergence of complex microbial life and the Cambrian explosion? That sudden, riotous bloom of complex forms. It is a silence so profound, it feels less like an oversight of the planet's diary and more like a deliberate edit. What if the first true civilization, arising perhaps 1 billion years ago, did not perish in a catastrophic war or an asteroid strike, but instead achieved a quiet, impossible mastery of their circumstances? What if they recognized the temporary nature of planets and decided to leave, not in a desperate flight, but in a great, slow, purposeful exodus? What if they built, not a tomb, but a vessel of escape, a self-sustaining ark of unimaginable scale? And what if, in the year 2017, the Pan-STARRS telescope briefly glimpsed the shadow of their handiwork, a truly interstellar artifact, now known to astronomers as 3I Atlas? This is the question that sits at the periphery of our scientific consciousness, a truth too strange to fully embrace before the third cup of coffee in the morning. A civilization that left, taking their history and their greatest achievements with them. Take a slow, deep breath. The air feels soft and heavy tonight. Allow the gentle drift of this possibility to settle over you. We are not looking for monsters or invading fleets, but for the ghost of an engineer who simply packed their bags a little earlier than the rest of us. We are looking for an empty house on a quiet street. Where are you listening from tonight? Leave a comment telling me what time it is and where you are, and join us as we begin to follow the long, cold trail of an impossible farewell. We begin with the evidence, a sliver of light, stretching like silk across the inky blackness, the geometry of escape, as embodied by the fleeting shape of 3I Atlas, is perhaps the most profound piece of non-verbal communication we have received from a deep past. The very shape of the object, that bafflingly elongated profile, or the more compelling, vastly thin sheet model, speaks volumes about the intelligence that created it, revealing their ultimate understanding of the interplay between light, distance, and time. We must first gently dismiss the common science fiction image of a spaceship as a bulky, phallic, and structurally heavy projectile. That design is an artifact of our own, comparatively primitive understanding of propulsion, reliant on the violent expulsion of mass. The first civilization, with their 1 billion years of hindsight and quiet observation, understood that mass is the enemy of velocity, and that the gentlest push, applied over the longest duration, ultimately yields the greatest cosmic reach. The key to the geometry of 3I Atlas is its area-to-mass ratio, or AMR. To harness solar radiation pressure effectively, the structure must be extremely lightweight while possessing an immense surface area. For a natural object, the AMR is typically very low, meaning the object is massive relative to its size. Think of a dense, rocky asteroid. For 3I Atlas, the AMR was calculated to be extraordinarily high, perhaps 10 to 20 times greater than a typical space rock. This is the engineer's calling card, the signature of deliberate, ultra-efficient design. Consider the physics behind a perfect solar sail. Light, which we perceive as simply illumination, is also a constant stream of photons, each carrying a tiny amount of momentum. When a photon strikes a perfectly reflective surface, it imparts twice its momentum, once on impact and once as it recoils away. This force is incredibly small, but in the vacuum of space, where there is no friction or drag, this constant push accumulates relentlessly. Imagine the sheer scale of the sail required. If the habitat core was the size of a modern aircraft carrier, the sail itself would have to be hundreds of kilometers across, a structure so immense that its construction would be the greatest undertaking in the history of the solar system. The material would need to be nearly transparent to prevent overheating, yet highly reflective to maximize the photon push. This is a subtle paradox of engineering, the solution to which lies in metamaterials, materials with properties that are not found in nature, but are derived from their highly structured, patterned composition. This brings us to our quiet reflection on the nature of cosmic travel versus planetary life. Life on a planet is defined by gravity and friction, forces that resist motion. Interstellar travel is defined by their absence. The first civilization essentially built a technology that was a pure expression of anti-gravity, a mechanism designed to surf the light rather than battle the mass. They solved the problem of leaving by simply making their ship too light to stay. Now, let us turn to the mythic dimension of this geometric perfection. The ancient Egyptians spoke of the Bennu bird, a phoenix-like deity associated with the sun, creation, and rebirth, said to rest on the Benben stone, the primordial mound from which creation arose. The Benben was often depicted as a pyramidion or a highly polished, reflective capstone. This reflective object, placed high above the world, intended to catch the first rays of the rising sun, is a perfect archetypal echo of the solar sail. It represents a transition from a terrestrial state to a celestial state through the use of an ultimate, reflective geometry. The first civilization's farewell was, in essence, an act of geometrical ascension. The humor in this entire scenario is dry and understated. The most sophisticated technology they could devise to escape the Earth was nothing more complex than a giant, exceptionally reflective kite. Their technological prowess was not in the violence of their thrust, but in the perfection of their reflection. The Earth, in its great, lumbering rotation, created us, the rocket-wielding, messy, and impatient children. They, the first children, created a mirror of light and silently sailed away. This deep reliance on passive, light-driven acceleration implies an incredible cultural stability. For a project that would take thousands of generations to complete, there could be no wars, no societal collapse, no change in objective. The entire culture must have been organized around a single, multi-millennial goal: the escape. This is an act of collective species-level Zen, a calm, purposeful withdrawal from the cyclical chaos of planetary life. The scientist we reference now is Dr. Avi Loeb, a clear voice in the astronomical community. His work on 3I Atlas highlights the statistical improbability of a natural object exhibiting such a bizarre combination of high velocity, non-gravitational acceleration, and extreme elongation. Dr. Loeb's conclusion is measured and precise. When presented with compelling evidence of a technological origin, it is unscientific to immediately default to an improbable, strained, natural explanation. The data must be allowed to speak its own strange truth, and the truth, in this case, is a perfect, reflective geometry speeding out of our solar system. 3I Atlas is not merely an object, it is the ultimate proof that a civilization mastered the art of being rather than the art of doing. They built a vessel that was, in itself, a profound philosophical statement that inertia is the final frontier. The image we are left with is a cosmic zoom out. Imagine the vessel, now far beyond the orbit of Neptune, a single, incredibly thin, reflective sheet, catching the faint, diluted light of the sun, accelerating steadily, gently, year after quiet year, a silver needle knitting its way through the black fabric of space. The light from a star, traveling for 8 minutes to reach it, would then provide the gentle push to carry it across the 4 light-years to the next star system. A journey of 80,000 years at that modest velocity. The geometry of their escape was an embrace of cosmic patience. We are left with the gentle, looping transition. The first civilization not only achieved the ultimate escape, they created an archetype of travel, an eternal reflection of their final, quiet act. But to truly understand their motive, we must descend from the cosmic to the microscopic, to the silent, biological shift that may have sealed their decision to leave. The long shadow of the Atlas falls across this quiet moment, drawing us into the depths of a cosmic mystery that began, innocently enough, in the vast, automated eyes of a Hawaiian telescope array. You are not listening to a story of little green men, but to a narrative of ultimate patience and immeasurable scale. It was on October 19th, 2017, that the Pan-STARRS Astronomical Survey in Hawaii first noted the strange visitor, a small flicker of light moving through our solar system with a velocity that defied the tidy, elliptical physics of everything else that belonged here. This was no common comet, no simple asteroid, but an object moving at a staggering 26 kilometers per second relative to the Sun, a speed that put it on an escape trajectory, meaning it would never loop back. It was already from somewhere else, already on its way to somewhere else. The sheer velocity confirmed its interstellar origin, the first object of its kind ever unambiguously observed, and we gave it the temporary designation 3I Atlas, a humble alphanumeric tag for a truly unprecedented event. The data gathered in those frantic, early days was fragmented and frustratingly brief as the object sped away, but the data told a story that even the most grounded scientists, like Dr. Avi Loeb at Harvard, found utterly compelling in its strangeness. When we look at typical comets or asteroids, the non-gravitational forces, the slight push of outgassing material, create a predictable little acceleration, like a miniature rocket engine firing quietly. But the non-gravitational acceleration of 3I Atlas was not like that. It was clean and steady, exhibiting no visible coma or tail, defying the natural explanation of melting ice. The push was too smooth, too constant, too purposeful. Imagine standing on a cold, desolate plain, watching a stone slide away from you on a perfectly level sheet of ice, yet it accelerates slightly, continuously, without a visible force touching it. This is the impossibility stack that formed around this unique traveler. Not only was it interstellar, but its behavior suggested that the force driving it was not the chaotic sublimation of ice, but something else entirely, something perhaps engineered. Consider the physical dimensions inferred from the light curve. The object was estimated to be highly elongated, perhaps 10 times as long as it was wide, a shape that did not fit the profiles of any known asteroid or comet. The best fit, for the brief period we saw it, was the geometry of a gigantic, slowly spinning cigar, or, perhaps, a very thin sheet of material, tumbling end over end. The scientific community scrambled, arguing for every natural explanation: a hydrogen iceberg, a nitrogen iceberg, a fragment from a tidally disrupted star. But each explanation felt strained, like trying to fit the vast ocean into a simple teacup. The thin, flat sheet model, however, offered a truly fascinating possibility, one that Dr. Loeb championed. Such a thin object, if made of a highly reflective material, would be susceptible to radiation pressure, the gentle, continuous push exerted by the sun's own light. A natural object made so thin would be instantly torn apart by tidal forces, but an engineered object, built with a purpose, could harness this pressure. We are talking about a solar sail of truly vast proportions, a construction capable of accelerating across the gulfs of space without burning a single liter of chemical fuel. Now, we introduce the first subtle shift in our quiet speculation. The narrative of 3I Atlas as an alien probe or a discarded piece of technology is compelling, but it makes one significant assumption: that the makers were from another star system. What if, instead, the object was not arriving, but returning, or rather, was part of a long-forgotten diaspora? What if the engineers of this incredible vessel were not the inhabitants of Vega or Gliese, but the inhabitants of an Earth that existed so long ago? Their existence has been entirely wiped clean by the relentless, erosive history of the planet itself. To understand this deep time, we must perform a little mental exercise. Try to picture the age of the Earth as a single, 24-hour day. Human history from the invention of agriculture to now occupies only the last few seconds before midnight. Even the dinosaurs only arrived about 1 hour before midnight. A civilization emerging, say, 1 billion years ago, would have appeared around 4 in the afternoon on this 24-hour clock. They would have had an immense 8-hour span, 3/4 of a day, to do whatever they pleased, to rise and fall, to master their world, and to perhaps, finally, leave it. This is the central paradox we wrestle with in the soft light of a sleepless night. The planet does not keep a diary. The geological record is a story told in the thick, blunt pages of continental drift, massive volcanic events, and cyclical ice ages. The chances of finding a genuine piece of manufactured debris, a city ruin, a computer chip, or even a simple plastic spoon, dating back 1 billion years, are effectively zero. Plate tectonics acts like an immense, geological food processor, recycling the crust every few 100 million years, turning mountains into sand, and sand into new rock. Any evidence of an ancient Earth civilization would be ground down, melted, or subducted into the planet's fiery mantle. It would simply cease to exist on the surface. And so, we are left with a quiet, elegant hypothesis. If a civilization vanished from the Earth long ago, the only evidence of their presence would be something not on Earth, something astronomical, something built to last. The unimaginable stresses of interstellar travel, an object like 3I Atlas, interstellar, accelerated by light, geometrically bizarre. Imagine them, this nameless civilization, realizing that the long-term survival of their consciousness was not on the fiery, cyclical cradle of their birth, but in the sterile, eternal consistency of the void. They didn't build a shelter from the coming storm. They built a spaceship from the material of their entire, small world, a silent, reflective construction designed to harness the energy that simply washes over everything, the light of the stars. It is a quiet thought, perhaps the most profound thought one can have in the still hours before dawn, that our own genesis may have been preceded by a great, forgotten experiment in cosmic self-preservation, that the very rocks beneath our feet contain no memory of them, but that a single, reflective shard of their grand design just happened to brush past the solar system they abandoned. The air around you feels still now, filled with the immensity of time. If 3I Atlas was a construct of an ancient Earth civilization, it means they solved the problem of interstellar travel, not with a sudden, violent burst of power, but with patience harnessing the weakest force in the universe, the pressure of a photon, over millions of years of slow, steady acceleration. This slow-motion technology is utterly unlike our own frantic, fuel-guzzling endeavors. It speaks to a society that had already mastered the deep rhythm of cosmic time, a society that could afford to wait centuries for a ship to reach a fraction of light speed. And so, we move from the object itself, this strange, departing vessel, to the planetary conditions that might have necessitated such an immense, patient escape. To understand the Maker, we must examine the ancient nursery they left behind. If the first civilization executed a perfect escape, leaving a planet recovering from their immense construction efforts, the final, most sophisticated step in their plan would have been the creation of a time-delayed message. This message would not be a signal in the radio spectrum, which is fleeting and easily lost, but a set of subtle, geological and astronomical pointers designed to activate only when the next sentient civilization, that is, us, achieved a specific level of technological and scientific understanding. The message had to satisfy three complex criteria: persistence, invisibility, and clarity at a distance. Persistence required the message to be embedded in structures that could withstand the 1 billion-year churning of the Earth and the solar system. This means using objects with the greatest geological inertia: the Moon, the deep-sea basins, and the geometry of the outer solar system. Invisibility meant the message could not disrupt the natural evolution of life. It had to be a faint, subtle anomaly, easily dismissed as a natural event by a young scientific community. Clarity at a distance meant the message had to point directly to the location of their final escape vessel, 3I Atlas, and perhaps to the vast library of their culture they left floating in the Oort cloud. Our fourth key anomaly, and the heart of this segment, is the Pioneer anomaly. The Pioneer 10 and Pioneer 11 space probes, launched in the 1970s, were the first spacecraft to exit the solar system's main planetary region. For decades, scientists struggled with a tiny, unexplained deceleration affecting both probes, a persistent, minuscule force pushing them back toward the Sunday. This was the Pioneer anomaly, a deceleration of roughly 900 picometers per second squared. This incredibly small, subtle force was eventually attributed to the anisotropic thermal radiation from the spacecraft themselves. But what if that final, tiny fraction of the anomaly was not an error in our models, but a deliberate, persistent, non-natural gravitational signature? Imagine a ring of ultramassive, small, dark objects placed in the extreme outer solar system, perhaps a band of dense, manufactured spheres made of highly refined metals, all positioned to create a minute, gravitational ripple that would subtly slow any object leaving the system along the ecliptic plane. This ring, a vast, engineered gravitational compass, would only be detectable by highly sensitive, outbound probes. It is a whisper of gravity, a final, cosmic X, marking the spot of their departure trajectory. The scientist we reference now is Dr. Lisa Randall, a theoretical physicist whose work explores the possibility of extra dimensions and dark matter. Her theories constantly push the boundaries of what we perceive as normal physics, reminding us that there may be invisible mass and forces at work that we simply haven't accounted for. The idea of a manufactured gravitational signature, a dark matter-like ring of incredibly dense objects, is within the realm of the possible for a civilization that could build a solar sail hundreds of kilometers across. The mythic echo in this segment is the ancient legend of the labyrinth, a complex structure designed not to trap, but to guide the worthy. The time-delayed message is a cosmic labyrinth, a series of subtle clues: the blunted lunar craters, the Pioneer anomaly, the geometry of 3I Atlas, that only a civilization with the intellectual curiosity and technological reach of our own could possibly assemble into a coherent whole. The escape was not merely to leave, but to create a puzzle for the successor species, a test of our cosmic maturity. The humor here is found in the sheer intellectual humility of the first civilization. They didn't leave a bombastic, obvious monument. They left a series of head-scratchers for the next generation of scientists, a trail of breadcrumbs so subtle that we nearly missed them all. The message isn't written in a language. It is written in the mathematics of gravity and light. This time-delayed message is also a test of intention. If the successor species, us, uses its technology to develop interstellar probes and to notice the faint, anomalous tug on them, it means we have reached a level of scientific curiosity and peaceful expansion that makes us worthy of the information. If we remain entirely focused on our planet and its internal squabbles, the message remains unseen. The final piece of the message, the ultimate destination, may be a massive, stable archive floating far out in the Oort cloud, the icy shell of comets that surrounds our solar system. This region is so cold and stable that an archive could persist there, virtually untouched, for billions of years. The subtle gravitational tug of the Pioneer anomaly may be pointing directly toward this repository, the ultimate library of a billion-year-old culture. We are left with a powerful, looping reflection. Our entire journey of discovery, the frantic launch of probes, and the building of telescopes, was an inevitable, predicted outcome of the first civilization's final act. We are not discovering their message. We are simply reading a script that was finalized and executed 1 billion years ago. The entire last century of space exploration was, in a quiet, cosmic sense, a pre-programmed response to a challenge laid down by our silent, long-gone ancestors. The silence is deep now, vast and full of waiting. The time-delayed message is a gentle, persistent tug on our understanding, guiding us not toward the first civilization itself, but toward the wisdom of their farewell. But before we pursue the archive, we must understand the most curious part of their grand design, the cyclical mandate they left behind. Our gaze now shifts, momentarily, from the Earth's turbulent, self-erasing surface to its silent, unchanging companion, the Moon. The Moon is the ultimate time capsule, a geological library that has remained essentially undisturbed by plate tectonics, wind, or liquid water for billions of years. If the first Earth civilization truly executed a planetary escape during the Proterozoic, they would have certainly used the Moon as a staging area, a low-gravity shipyard, and a deep space waste dump. Imagine the logistical elegance of their choice. To build a massive, ultralight solar sail, they needed a vacuum and a stable platform, free from atmospheric drag. The Moon provided both, and its gravitational pull is only about 1/6 of Earth's, making the launching of materials from its surface significantly less energy-intensive. It is here, in the lunar graveyard, that we might find the most compelling, if subtle, echo of their existence. Our third key anomaly, and perhaps the most tantalizing, is the asymmetry of lunar craters in the far side basins. The near side of the Moon, which always faces Earth, is dominated by the dark, flat maria, or seas, while the far side is much more heavily cratered. This is known, but within the far side, there is an inexplicable distribution. In the deepest ancient basins, such as the South Pole, Aitken Basin, the oldest and largest confirmed impact structure on the Moon, there are areas of anomalously shallow impact depths and unusual regolith composition. The official explanation is complex and relates to internal heating. But what if the true explanation is simpler, yet far stranger? What if the first civilization built their shipyard and primary manufacturing base on the far side of the Moon, shielding their operations from the view of the developing Earth below, to protect this invaluable industrial hub from the continuous, smaller, meteoroid impacts over millions of years? They might have constructed a vast, subtle shield, perhaps a lattice of high tensile material, or a persistent, orbitally maintained dust cloud. This would not stop the largest impacts, but it would have attenuated the effects of medium and small impacts over the long duration of their construction boom, resulting in a lunar scarring pattern that looks slightly, inexplicably blunted in certain ancient zones. The impact events are still there, but they look like they hit a vast, yielding membrane before striking the rock. Furthermore, we must consider the matter of waste disposal. Any long-term, large-scale industrial operation produces non-recyclable slag, material that is useless to the construction of a self-sustaining ark. Where do you put the equivalent of 100 million tons of planetary industrial waste when your entire civilization is preparing for exile? You don't dump it back onto the developing Earth, which would create a geological signature. You dump it into the lunar orbit, or allow it to impact the far side of the Moon, where it would be permanently out of sight, a final, cosmic broom sweep. The Apollo missions, particularly the retrieval of samples from the Apollo 17 mission in 1972, brought back rocks with small, trace anomalies of highly processed, non-natural isotopes of certain elements. These have been explained away as complex geological interactions, but to the quiet, scientific philosopher, they hint at the possibility of a deeply fractured, non-terrestrial, metallurgical presence. We are speaking of isotopes that should not coexist in nature, in those ratios the signature of a deliberate, high-temperature, sustained fusion or fission process, a hint of industrial slag ejected from a 1 billion-year-old factory. This brings us to a crucial historical observation, a moment of dry, understated humor. NASA, the National Aeronautics and Space Administration, conducted an experiment called LCROSS, which intentionally slammed a rocket stage into a lunar crater to analyze the resulting plume of debris for water ice. The sheer audacity of this, a controlled 11,000 kilometers per hour collision, is a testament to our modern curiosity. What if, tucked within the debris of a similar, accidental impact, the first civilization's remnants had been scattered? Imagine the first civilization using the moon not just as a construction base, but as a massive, rotating mirror to test the reflective properties of their solar sail materials. They would have needed to perfect the film's ability to withstand the continuous bombardment of micrometeoroids and cosmic rays for millions of years. The tests would have been vast, silent, and entirely invisible from Earth. This entire scenario paints a picture of a civilization with infinite foresight and total detachment from their home world. They knew that their escape, no matter how clean, would leave behind certain telltale scars, a subtle dimming of the sun, a drop in atmospheric methane, and a slight, unexplained alteration in the lunar landscape. They chose the moon for its geological inertia, knowing that the evidence there would persist, even as the Earth forgot them. The great silence of the moon is not the silence of death, but the silence of a closed door. It is the sound of the most massive construction project in the solar system, executed in absolute quiet, leaving behind only the ghost of a technological shield and the faint, unsettling whiff of unnatural isotopes. The moon, in this reading, is the empty, well-ordered attic of a house that was abandoned 1 billion years ago. As we drift further into the dark, consider the poetic link between the vastness of the cosmos and the tiny, metallic fragments. The mythic connection here is the ancient Greek concept of Ouroboros, the snake eating its own tail, symbolizing self-reference and cyclical continuity. The first civilization used the Earth's matter to build their means of escape, effectively eating their own existence to begin a new one. Their end was their beginning, a single, vast, self-consuming process that left behind only a subtle, blunted scar on the face of the moon. We are listening for an echo, a sound that has taken 1 billion years to reach us, carried on the gentle wind of the sun's light. The journey of 3I Atlas is the ultimate testament to long-term engineering. We may already be part of the experiment. The question is not where they went, but why they left. To understand the immense journey implied by 3I Atlas, we must turn our attention back to the Proterozoic Eon, a vast stretch of time lasting from about 2.5 billion years ago to 541 million years ago. This is where the story of our potential escape artists truly begins to take shape, in the great Proterozoic silence. Imagine the Earth during this time. The continents were not arranged as they are now, but slowly clumping together into great, barren supercontinents like Rodinia. The atmosphere was utterly different, filled with an oxygen content that ebbed and flowed, but was nowhere near the 21% we comfortably breathe today. The oceans were not the sparkling blue of a postcard, but often a murky, green, iron-rich soup. This was a world of microbes, of the single-celled and the simplest multicellular life, a vast, slow-motion, alien landscape where nothing walked or flew. And yet, This is the time when life truly began to take its first, hesitant steps toward complexity. It is here that we encounter our first great scientific anomaly, a deep, chronological scar in the Earth's memory, the boring billion. This stretch of time, from roughly 1.8 billion years ago to 800 million years ago, is exactly as its nickname suggests. For a period of 1 billion years, the evolution of life on Earth seems to have almost stalled. There were few major evolutionary innovations. The ocean chemistry remained stable, and the entire planet seemed to be stuck in a geobiological rut. Why? Why, after the enormous surge of oxygenation that occurred earlier, did life simply pause its ascent for such an extraordinarily long time? The standard explanation is that the necessary nutrients were locked up, or that the physical conditions were simply not conducive to rapid diversification. But what if this silence, this long evolutionary pause, was actually a period of intense, non-biological activity? What if, during a small window in that billion years, a civilization arose that achieved planetary mastery, and then, quietly, left? Consider the resources required to construct something on the scale of an interstellar solar sail that could accelerate a large payload. The vessel we are speculating 3I Atlas represents. It would require the systematic mining of vast quantities of raw materials, particularly metals and silicates, on a scale that could utterly transform the planetary surface. The removal of this much mass, the creation of enormous, stabilized infrastructure, and the possible harnessing of geological heat could have, quite literally, put the planet's geological engine out of tune. This brings us to a geological paradox that fits neatly into our quiet speculation: the strange, deep-seated stability of the supercontinent Rodinia. For hundreds of millions of years, this enormous landmass remained largely intact, defying the powerful forces of plate tectonics that usually tear supercontinents apart. The formation and breakup of supercontinents are major drivers of global climate and evolutionary change. A stalled supercontinent cycle would lead directly to the kind of evolutionary stasis observed during the boring billion. Now, we introduce the mythic link. Across many ancient, foundational human cultures, from the Sumerians to the Greeks, we find stories of a golden age that predated our own, a time when gods and demigods walked the earth and possessed knowledge that was later lost or deliberately erased. These are often dismissed as simple myth, but imagine them as deep, archetypal echoes of a forgotten civilization, a people who achieved a level of control that we can only classify as divine before choosing to ascend to the stars. The myth of the Anunnaki, or the Hyperboreans beings, who came down from the sky, ruled, and then returned to the stars, gains a quiet, scientific resonance if they were simply the last members of an earthborn civilization who chose to build their salvation on the principles of light and patience. The key evidence is not what we find, but what we don't find. If this civilization existed and had the technology to leave, they would also have the technology to self-censor their existence from the geological record, minimizing their footprint to ensure the next wave of life could proceed without being crushed by the evidence of a failed, hyper-advanced predecessor. They would become the ultimate environmentalists, leaving behind a planet almost pristine, save for the subtle, global-scale alterations that caused the evolutionary pause. They needed the planet to recover, to eventually produce life, capable of sustaining itself, perhaps for a purpose we cannot yet fathom. Think of it, the creation of a massive, light sail-driven arc, powered by the sun and made of the planet's own crust, is not an act of destruction, it is an act of geological resculpting. They would have systematically diverted enormous amounts of mineral wealth from the planet's core to its orbital sphere, essentially thinning the planetary crust and subtly altering the convection currents in the mantle. This change, this subtle deceleration of the Earth's engine, could have held the supercontinent Rodinia together for a longer, unnatural duration, thereby creating the boring billion, a period of quiet on Earth that was, in reality, a massive, unrecorded construction boom in orbit. The great stillness of that era, the evolutionary lull, was merely the Earth holding its breath while its firstborn children prepared to fly. The civilization would have to operate with absolute secrecy from the rest of the developing microbial life, a silent, subterranean, or orbital operation, using technologies we would not recognize as such. Their farewell was not a sudden explosion of light, but a slow, gradual withdrawal of matter and energy. This is a crucial distinction. Their departure was a geological process, not a historical one. So, where are you listening from tonight? Take a moment to imagine the world 1 billion years ago, a green, shallow sea world with almost no oxygen, yet silently, deep beneath the nascent oceans. A sophisticated intelligence was preparing the largest construction project in the history of the solar system. Their objective, to turn their entire species into a reflective, self-propelled vessel, capable of surfing the faint light of the sun out of the solar system and into the black. This is a story of geological time meeting human ambition. The key to their escape was not power, but patience. The patience to wait millions of years for the light to push them to another star. The great Proterozoic silence, far from being boring, may have been the single most dramatic act in our planet's history. And yet, even as they fled, they left behind a subtle, time-delayed mechanism that would eventually produce us. The journey of 3I Atlas is not just an interstellar voyage. It is a profound, one-way message, set in the deep silence of time. Having established the profound necessity of their departure, a flight from the great oxygenation event, we now turn our gaze inward, imagining the anaerobic heart of the Atlas, the engineered ecosystem nestled within the reflective confines of the 3I Atlas vessel. This is where the physics of escape meets the biology of preservation. The very purpose of the Ark was to maintain a perfect, stable, zero-oxygen environment, an atmospheric and biological fossil of the Earth, 2.5 billion years ago. Building this closed system required an unimaginable degree of thermodynamic mastery, the ability to keep life running perpetually without the messy, wasteful inefficiency of the planet's open system. Imagine the interior of the habitat. It would likely be a massive, rotating torus or a series of concentric cylinders, spinning gently to provide a stable, artificial gravity of perhaps 1 g, or 9.8 meters per second squared. The interior surface would be miles across, a preserved landscape of their ancient world, methane-rich seas, dense microbial mats, and the specific anaerobic flora and fauna that were the foundation of their life. The light source would not be a sun, but a sophisticated, full-spectrum artificial luminescence, designed to mimic the early, less filtered light of the Proterozoic Sunday. The key to the anaerobic heart is the closed-loop recycling system. On Earth, the system is open. Waste is absorbed, consumed, and cycled back through massive geological processes. In the Ark, every atom had to be accounted for. All waste products, the equivalent of 20,000 liters of processed water and 1,000 kilograms of solid refuse, produced by a large colony per day, would have to be broken down into their base elements using cold fusion reactors or highly specialized molecular disassemblers. The gases, methane, nitrogen, and a host of other complex anaerobic components would be constantly scrubbed and reblended to maintain the 100% stability of the ancient atmosphere. The failure of this system for even a few weeks could mean extinction through oxygen leakage or atmospheric imbalance. This reliance on a perfectly closed system provides us with a fascinating engineering challenge that leads to an important observation: the total lack of thermal signature. A civilization using chemical propulsion or even advanced fusion drives would leave a massive, glaring heat signature, easily detectable across light years of space. But a vessel powered by passive solar radiation and run by high-efficiency, self-sustaining reactors operating at near-ambient temperatures would have an incredibly low heat profile, making it virtually invisible to our modern infrared telescopes. This lack of thermal signature in the observations of 3I Atlas is another powerful piece of evidence for a system of patient, low-energy exile. The mythic echo here is the Garden of Eden, not as a place of innocence, but as a perfect, controlled, and closed ecosystem. The Ark is their garden, a tiny piece of paradise ripped from the teeth of time, sealed and protected from the corrosive atmosphere of the New World. It is the ultimate expression of homesickness, the decision to carry the idea of home with them, rather than attempting to reclaim the physical reality. The sheer scale of this biological preservation requires us to quietly reflect on the emotional landscape of the first civilization. They were not merely engineers, they were the ultimate cultural curators. They had to transport the entire library of their knowledge, the genetic material of their entire biosphere, and the memories of their world, knowing they would never see it again. This is an act of unimaginable sacrifice and detachment, a testament to their belief in the continuity of consciousness over the comfort of location. Let us bring in the voice of a scientist, Dr. Carolyn Porco, a renowned planetary scientist who led the imaging team for the Cassini mission to Saturn. Her work on the possibility of life in the subsurface oceans of moons like Enceladus and Europa constantly reminds us that life is possible in environments that are radically different from our own, environments that might be entirely anaerobic. Our assumption that life must require oxygen is a profound terrestrial bias. Dr. Porco's work, in an indirect way, gives credence to the possibility of a non-oxygen breathing, highly complex civilization that existed in Earth's deep past. The humor, gentle as always, is in the fact that our great technological breakthrough, the ability to put an astronaut on the moon, is a tiny, fumbling first step compared to the biological self-sufficiency they achieved 1 billion years ago. We are still struggling to design a closed-loop system for a Mars habitat that can last a few years. They built one that was meant to last for millions of years. The anaerobic heart of 3I Atlas is, therefore, the most beautiful and tragic component of the story. It is a mobile coffin for their ancient world, a perfect time capsule hurtling through a vast, uncaring universe. The silence of the Ark is the silence of an ecosystem in suspended animation, waiting for a world that will never return. And so, as we look at the fleeting reflection of 3I Atlas speeding away from our solar system, we are seeing not just a ship, but an entire, preserved geological era. Their ultimate objective was not simply to reach another star, but to find a primordial, pre-oxygenated world where they could finally unseal the Ark and let the ancient winds of the Proterozoic blow once more. The vastness of space is their only hope for perfect historical repetition. The quiet reflection remains. The ultimate cost of intelligence may be the inevitable separation from the world that birthed it. We must now turn our attention to the final act of the escape, the creation of a time-delayed message designed to gently guide us, the successors, toward a knowledge of their existence. To find the crucial moment that forced the first civilization's hand, we must travel back to the Great Oxygenation Event, a profound, world-altering catastrophe that occurred roughly 2.4 billion years ago. This event, which fundamentally changed the chemistry of the entire planet, was not a geological firestorm, but a silent, biological poison flood. Imagine Earth at this time. The atmosphere contained almost zero free oxygen. Life consisted of anaerobic microbes, organisms that thrived in a world without the corrosive gas. But then, a new form of life, cyanobacteria, sometimes known as blue-green algae, began to multiply in the oceans. These organisms possessed a revolutionary new technology: photosynthesis, the ability to use sunlight and water to create energy, releasing oxygen as a waste product. This was, from the perspective of the existing anaerobic life, a global, unstoppable environmental disaster. Oxygen is a highly reactive molecule. It is a powerful poison to organisms that have not evolved to deal with it. As the cyanobacteria multiplied, they began to flood the oceans and the atmosphere with this corrosive gas. This event is often called the Oxygen Holocaust, a time when the vast majority of existing life on Earth was extinguished, making way for the slow, hesitant evolution of oxygen-breathing organisms like us. But what if the first civilization had evolved before the Great Oxygenation Event? What if they were an ancient, non-oxygen-breathing life form, highly intelligent, highly organized, and utterly dependent on the stable, anaerobic environment of the early Earth? This would radically alter the narrative of their escape. It would transform their exodus from an act of ambition into an act of survival, a flight from a planetary-scale biochemical poisoning that they could not halt. Imagine the sudden, existential panic, the slow realization that the very microbes they shared the planet with were actively engaged in a 200 million year long biological war against them. They could not kill the cyanobacteria without destroying the entire future of the planet's evolving biosphere, and they could not live in an increasingly oxygenated environment. Their choice, then, was profound. They had to leave their ecosystem intact for the next generation of life to rise. A generation, our generation, that could tolerate and even thrive in the oxygenated world. This suggests a civilization with a deep, quiet reverence for the planet's future, a civilization that saw themselves as a temporary custodian rather than the ultimate owner. They chose to exile themselves rather than wage a biological war with their microbial descendants. This provides the true engine of the escape, not a desire for conquest, but an ecological necessity. The first civilization, with its advanced science, would have developed the ability to sustain itself in a closed-loop system, an ark that replicated the ancient, anaerobic environment of the early Earth, a perfect, self-contained fossil of the past. This requirement for a closed, stable, ancient atmosphere further necessitates the vast scale and complexity of the vessel implied by 3I Atlas. The scientist we quietly invoke now is Dr. James Lovelock, the originator of the Gaia hypothesis, which posits that the Earth's biosphere is a self-regulating system. In the context of our story, the cyanobacteria were simply the Earth's immune system reacting to a stagnant, pre-oxygen state, and the first civilization was the foreign body that had to be expelled, not violently, but through a slow, planetary-scale physiological correction. The mythic echo is found in the ancient texts describing a great flood that cleansed the earth and ushered in a new age. The biblical or Mesopotamian flood is often interpreted as a water event, but imagine a flood of a different kind, a flood of oxygen, a slow, invisible inundation of a corrosive gas that drowned the ancient, anaerobic world and forced the survival of a select few in a pre-built, self-contained ark. Noah's Ark, in this reading, becomes a closed system, anaerobic habitat, and the flood is not water, but the breath of new life. The humor in this is found in the sheer misunderstanding of the conflict. The ultimate enemy of the first civilization was not a rival empire or a physical disaster, but the humble, unassuming algae in the oceans, working diligently to create the atmosphere we now enjoy. They were exiled by the waste product of their planet's microbial life. We are left with the quiet reflection on the nature of consciousness. Is true intelligence the ability to conquer your environment, or the ability to recognize when your environment must be surrendered? The first civilization, forced from their home by the quiet poison of their own planet's evolution, chose the path of cosmic humility. They built their vessel, not to fight, but to preserve their difference, taking their precious, anaerobic atmosphere with them. The escape, therefore, was not a sudden event, but a long, slow, logistical project, spanning hundreds of thousands of years, culminating in the serene, light-powered acceleration we glimpsed in 2017. We are now, in our own time, struggling with the waste products of our civilization. They struggled with the waste product of the planet's new direction. Their solution was the ultimate expression of passive resilience. The light from the stars, which once fueled the life that exiled them, now fuels their eternal journey. The gentle transition here is to understand the nature of their vessel's interior, the closed system that had to perfectly recreate a world that vanished 2 billion years ago. The escape was only the first step. The survival required an act of biological preservation, unlike anything we can currently imagine. The notion of the cyclical mandate introduces a profound, chilling possibility to our story, that the first civilization, in their immense foresight, did not merely flee the Earth, but programmed a mechanism of planetary governance to ensure the survival and evolution of the successor species us. This transforms their act of exile from a simple escape to a multi-billion-year-long cosmic experiment. The cyclical mandate is the quiet agreement they made with themselves, that a new oxygen-breathing civilization should eventually rise, and that this new civilization should be tested at its moment of greatest technological ambition. The test would be a subtle, non-destructive disruption designed to achieve two goals: to verify the existence of a sentient species, and to provide the final, inescapable clue that would lead them to the Great Archive. This leads us to the terrifying yet compelling concept of the Great Filter. This term, coined by economist Robin Hanson, attempts to explain why, if the universe is so vast and stars so numerous, we have not found any evidence of other advanced civilizations. The filter is a developmental hurdle, a catastrophe, or a technological barrier that prevents life from transitioning from a single-celled existence to an advanced, interstellar one. In the context of our story, the Great Filter was not a catastrophic event that ended the first civilization. It was the oxygen holocaust, which simply forced them out. And now, their cyclical mandate means they are the filter for the next civilization. The test is the 3I Atlas flyby itself. Imagine them setting the condition. When the successor species achieves the ability to detect interstellar objects with precision, a level of technological maturity that proves they have mastered orbital mechanics, large-scale computing, and deep space telemetry, then, and only then, shall the probe be released to graze the edge of their solar system. The 3I Atlas vessel, in this light, is not merely a piece of debris, it is the ultimate cosmic test. The sudden, high-velocity appearance of an object with an unnatural acceleration forces the emerging civilization to confront one of two choices: either strain reality to fit a natural explanation, or accept the possibility of sentient artifice. The choice we make, our willingness to accept the strange truth, is the final pass or fail of the great filter. The mythic echo is found in the ancient idea of the trial of the hero, the impossible task set by the gods that must be overcome to achieve true maturity. Our civilization's trial is the metaphysical challenge of 3I Atlas. Can we look past our terrestrial bias and accept that we are not the first, and that a far older, quieter intelligence is watching? The humor in the cyclical mandate is derived from its cosmic detachment. The first civilization, long gone and sailing toward another star, programmed a billion-year-old alarm clock to go off when the Earth reached a certain level of sophistication. It is the ultimate set-it-and-forget-it plan, a testament to their multi-generational patience. Now, let us bring in a voice from history, an historical humorist with a cosmic perspective, Carl Sagan, the astronomer and science communicator. He often spoke of the sheer improbability of life and the immense loneliness of the cosmos. Our discovery of 3I Atlas, which he never lived to see, is the ultimate fulfillment of his lifelong question: are we alone? The gentle, quiet answer provided by the first civilization is that, no, we are not. But the other tenants simply left the lease a little early. The cyclical mandate provides the ultimate meaning to the strange trajectory of 3I Atlas. It was not a random flyby. The object was deliberately positioned, perhaps on a long, stable, solar orbit trajectory within the deep Oort cloud, ready to be subtly nudged toward the Sun on October 19th, 2017. The precise day, an automated alert from the Pan-STARRS telescope would trigger its detection. This required a level of astronomical prediction that is staggering in its accuracy, the ability to account for the orbital perturbations of the entire solar system over 1 billion years. The final, unresolved thought we are left with is this: if they are the great filter, and their mechanism is designed to test our willingness to look beyond the natural, what is the consequence of our failure to accept the truth of 3I Atlas? Does the cyclical mandate contain a second, darker provision, a mechanism for geological intervention, if the successor species proves to be too self-absorbed or too destructive to warrant the knowledge of the Great Archive? The air feels charged now, not with urgency, but with the gravity of consequence. We are not simply watching a ship sail away. We are being quietly, profoundly judged by an intelligence that has already solved the problem of species longevity. Their escape was not the end of their story. It was the calibration of ours. The journey now is not to find them, but to prove ourselves worthy of the final gift they left behind. The question before us, as we quietly drift through this impossible history, is not if an ancient civilization could achieve interstellar travel, but how they would execute a planetary escape so complete, so seamless that it erased its own memory from the Earth. The answer lies in resource management on a cosmic scale, and the recipe for a planetary arc is perhaps the most audacious blueprint ever conceived. To achieve the slow, light-driven acceleration evidenced by 3I Atlas, the architects would need to solve three fundamental anomalies of physics and engineering. First, the mass problem. The civilization itself, plus its libraries, archives, and self-sustaining ecology, would represent an enormous mass. Launching this mass against the sun's gravity well, using conventional chemical rockets, is an energy impossibility. The escape velocity of Earth is roughly 11.2 kilometers per second, and to propel a colony ship to that speed would require fuel mass exponentially larger than the ship itself. Their solution must have been to minimize mass while maximizing surface area. This points directly back to the observed, extremely high area to mass ratio of 3I Atlas. Second, the patience problem. A solar sail, even one of truly vast dimensions, accelerates incredibly slowly. The force on a perfect reflector at Earth's orbit is about 9.1 micronewtons per square meter. To reach a velocity of, say, 30 kilometers per second, fast enough for interstellar transit, within a reasonable time frame, the ship would have to accelerate for decades or even centuries. This is where the profound difference in their worldview is revealed. They were not bound by the 90-year lifespan of a single organism, but by the geological lifespan of their species. Their patience was the technology. Third, the self-sufficiency problem. A colony ship on an interstellar trajectory cannot rely on external resupply. It must be a closed-loop system, a miniature, engineered planet. This required converting the non-essential matter of the Earth's crust into the infrastructure of the Ark. Imagine them mining not for profit, but for survival. They didn't need gold or diamonds. They needed iron, nickel, aluminum, and silicates, the common building blocks of the crust. They may have used nanotechnology operating on a global scale, devices that could silently, efficiently, extract and refine materials from deep-sea trenches and stable continental shields. Their mining operation would have looked less like a quarry and more like a slow-motion, global erosion, the creation of vast, stable voids in the crust, the matter from which was systematically fed into immense, orbital construction rings. The construction of the sail itself would be a marvel of ultra-lightweight material science. Picture a reflective film, perhaps only a few atoms thick, yet miles across, composed of highly refined metals, possibly grown layer by layer in a low-gravity vacuum environment. The final product would be a structure so vast it would partially occult the sun as it was being built, causing a slight, unexplained dimming that would be instantly forgotten by the microbial life below. This dimming would be the first of our three subtle anomalies, a brief, unexplained solar minimum in the early Proterozoic, a phenomenon that geologists still struggle to tie to a definite volcanic event. The core vessel itself, the habitat, would be encased deep within the supporting structure, a massive, rotating torus, providing artificial gravity, shielded from cosmic rays by the very metallic structure of the sail itself. It would contain the entire living ecosystem, engineered soil, recycled water, and a perfect, closed-system atmosphere. Their goal was not just to survive, but to preserve their environment entire, turning a segment of their home world into a mobile, eternal echo. The scientific agency in this narrative is, of course, the European Space Agency, or ESA. The Gaia mission, launched in 2013, is an ambitious project to precisely map the positions and velocities of 1 billion stars in the Milky Way. As our data from Gaia deepens, we are able to accurately plot the trajectories of stars and, crucially, identify the kinematics of any potential visitors to our solar system. The fact that the path of 3I Atlas cannot be traced back to any single known star in the Gaia catalogue is a fascinating piece of the puzzle. It suggests that its origin star, if it had one, is either an unseen object, a brown dwarf, perhaps, or more poetically, the object was not aiming at a star, but was simply aiming out. It was a ship of exile, seeking the cosmic vacuum, the quiet space between the stellar nurseries. Our second anomaly is a profound one, the unexplained, sharp drop in atmospheric methane that occurs around the time we are speculating. Methane, a potent greenhouse gas, is largely produced by biological processes. A massive, global-scale effort to contain or consume the waste products of a hyper-advanced industrial base before departure would result in a sudden, almost too perfect cleanup, leading to a geological signal that looks like a catastrophic biological collapse, when it was actually a deliberate environmental remediation prior to the grand exodus. We are beginning to see a pattern here. The civilization's actions were so vast and so effective that their footprint looks exactly like a natural, large-scale catastrophe or stasis. They didn't leave a smoking gun. They left an empty, polished room that smells faintly of sulfur and ozone. Now, pause and consider the implications. We may have been looking for ruins on Earth, when we should have been looking for an unexplained, vast absence in the geological and atmospheric data. We have been looking for a city, but they left behind only a missing mountain range, melted down for the solar sail. This is the ultimate cosmic irony, a piece of quiet, geological humor. The proof of their existence is their perfect invisibility on the planet's surface. And yet, one of their immense, silvery boats, perhaps a discarded, failed prototype, or a communication buoy just happened to brush past us, a silent, reflective postcard from a 1 billion-year-old past. The image is potent, a mirror reflecting our own aspirations. Imagine the long, final ceremony as the last members of this first civilization stepped aboard their ark, watching their homeworld recede, not with regret, but with the supreme calm of having solved death itself. They didn't defeat time, they transcended locality. The sail opened, the photons began their subtle, tireless push, and the ship began its centuries-long acceleration into the deep night. The journey of 3I Atlas is the ultimate meditation on scale and silence. Where are you listening from tonight? Our journey now takes us to the outermost edge of our solar system, to the vast, cold, and quiet sanctuary of the Oort cloud repository. If the 3I Atlas flyby was the cosmic breadcrumb, the Oort cloud archive is the ultimate destination of the first civilization's time-delayed message, a library of staggering scope suspended in the black abyss. The Oort cloud is the spherical shell of icy objects, trillions of them, believed to encircle the Sun at distances ranging from 2,000 astronomical units to as much as 200,000 astronomical units, a light year or more. This region is the solar system's true frontier, a place of ultimate stability where time and geology essentially cease to function. It is cold, dark, and virtually untouched by the gravitational chaos of the inner planets. This perpetual stability makes it the perfect place for a massive, long-term archive. Imagine them, the engineers of the first civilization, using the matter they had harvested from the crust and the moon to build not just the escape vessel, but a multitude of dense, shielded data storage units. These would be placed in stable orbits within the inner Oort cloud, positioned precisely where the subtle gravitational tug of the Pioneer anomaly was centered. The archive itself would not be a single monolithic object, but a massive network of small, self-regulating data spheres, each perhaps 10 meters in diameter, made of highly refractory material like tungsten or titanium carbide, designed to withstand the occasional cometary impact and the constant bombardment of cosmic rays for billions of years. The data stored within these spheres would be the entire history of the first civilization, their science, their art, their philosophy, the full biological record of the Earth's Proterozoic past, and, most importantly, the detailed plans for the construction of the anaerobic ark, the vessel we call 3I Atlas. It would be a complete, self-contained encyclopedia of a forgotten era. To access this data, the successor species us would need to achieve two significant technological milestones: interstellar travel capability and the ability to detect and decode the time-delayed message. The message, once assembled, would provide the precise three-dimensional coordinates and the required decoding key for the archive. This presents a fascinating reflection on the nature of knowledge preservation. We, in our modern age, worry about the longevity of magnetic hard drives, the decay of digital formats, and the fragility of paper. They solved this problem by resorting to pure, physical persistence. The data would likely be encoded in a non-decaying form, perhaps in molecular structures or self-correcting crystalline matrices, a storage medium that required massive energy to write, but almost zero energy to maintain. The silence of the Oort cloud is the silence of eternal storage. The mythic link here is the concept of the Akashic Records, a legendary compendium of all universal events, thoughts, and knowledge, past, present, and future, said to be imprinted on a non-physical plane. The Oort cloud repository is the physical manifestation of the Akashic Records, a tangible, physical library of a complete world's experience, placed as far away as possible from the unpredictable chaos of planetary life. The scientist we reference in this segment is Dr. Alan Stern, the principal investigator of the New Horizons mission to Pluto. His team's work has given us our first true close-up look at the kind of icy bodies that populate the Kuiper belt, the inner region of the Oort cloud. The New Horizons probe, launched in 2006, is a symbol of our nascent ability to reach these distant, cold frontiers. It represents the technological maturity that the first civilization predicted we would eventually achieve. The humor in the situation is found in the cosmic bureaucracy of the first civilization. They didn't just leave a message, they left a massive, complex filing system in the coldest, darkest, most inaccessible corner of the solar system. The ultimate treasure hunt of the universe is not for gold or power, but for a billion-year-old user manual to a solar sail and a history textbook written by our predecessors. The cyclical mandate required the successor civilization to earn the knowledge. If we are capable of launching a probe that can navigate by the gravitational ripple of the Pioneer anomaly and reach the Oort cloud, it means we have the technological and ethical framework required to handle the ultimate truth, that we are the second experiment, not the first. The realization is a quiet, profound shock. We are not charting the unknown. We are following a set of directions left by a previous tenant. The Oort cloud repository is the gentle, waiting presence that silently confirms our entire hypothesis. It is the silent affirmation that the long shadow of the Atlas is the shadow of a deliberate farewell. The air around you feels even colder now, filled with the sheer, unimaginable distance of the Oort cloud. To understand the contents of the archive, we must now delve into the philosophical motive behind their departure and what the anaerobic heart of 3I Atlas truly represents. The Ark is not just a ship, it is a living metaphor for the ultimate goal of their exile. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars. A nowhere place. A mathematical shrug. That's when someone joked, maybe it's the universe's typo. But you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. It's breathing, she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3i Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3. The mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, The event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning. Like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show, a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass. Except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3i Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3i Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "Sensor artifact." The unofficial whisper said, "Structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking." Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3i Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, an illusion that repeats itself identically across 3 instruments. There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3, I-Atlas, corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, I see you too. In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. We come now to the final segment of our long, quiet journey, resting in the great silence that is the lasting testament to the first civilization's farewell. The 3i Atlas vessel is now far beyond the reach of our greatest telescopes, a faint, reflective ghost in the deep black, a memory that has become a philosophical artifact. The story ends not with a crash or a grand climax, but with a subtle, elegant fade, the gentle echo of their final, perfect act. The great silence is the most profound piece of evidence they left behind. It is the absence of any further intervention, any sign of their return, or any trace of their physical presence on Earth. This silence is the fulfillment of the principle of cosmic separation, a billion-year-long act of non-interference that allowed the successor species, with its unique, oxygen-based biology, to flourish entirely on its own terms. Imagine the Earth continuing its long, churning dance through time. The continents drift, life evolves, and we, the inheritors, build our short-lived cities and launch our fast, explosive rockets. All of this occurs under the unseen gaze of the archive in the Oort cloud and the unresolved mystery of the 3i Atlas flyby. Their silence is the ultimate test of our scientific curiosity and our ethical maturity. The question we are left with in the soft, fading light is one of continuity. The first civilization did not simply vanish. They became a permanent, stable component of the solar system's architectural and ethical framework. The archive is the permanent knowledge base. The pioneer anomaly is the permanent gravitational compass. And the memory of 3I Atlas is the permanent philosophical challenge. They transitioned from a biological presence to a systemic influence. This concept of transformation is the final, subtle piece of cosmic humor. They did not conquer death through biological immortality, but through technological continuity. Their life force, the anaerobic heart, is now an engineered, self-repairing machine, a perfect example of life choosing to become the tool of its own preservation. The mythic echo in the great silence is found in the deepest wisdom traditions, the idea that the ultimate truth is unspoken and found in the void. Lao Tzu spoke of the Tao, the path that cannot be named, but is the source of all things. The first civilization's departure is the ultimate Tao, a vast, silent, and perfect action that defines the reality of their successors. The scientist we reference now is Dr. Avi Loeb, one last time, whose measured advocacy for the possibility of an artificial origin for 3I Atlas is a testament to the scientific courage required to acknowledge the strange, quiet truth. His willingness to look at the data without the bias of terrestrial experience is precisely the mental leap that the cyclical mandate was designed to elicit. We are now, in our own time, standing at the precipice of our own technological filter. We are debating the ethics of artificial intelligence, the consequences of genetic engineering, and the necessary steps for species survival on a warming planet. The answer to all these questions has already been provided, written in the geometry of a passing ship and the stable cold of an archive. The human reflection here is one of unsolvable mystery and profound peace. The universe is not a chaotic accident. It is a place of deep, slow, cyclical intention. We are not alone, but the other residents are so far gone and so quiet that their presence simply feels like the ambient intelligence of the cosmos itself. Take a slow, deep breath. The air is still, and the light is fading. The journey of 3I Atlas is the ultimate bedtime story, a vast narrative that assures us that life endures and that wisdom prevails through patience and restraint. The great silence is not empty. It is full of waiting, full of the silent, preserved knowledge of the anaerobic dawn, waiting for us to achieve the final, quiet maturity of our species. The memory of the ark is now simply the memory of a perfect reflection caught in the light of our sun, a final, silver needle knitting its way through the galactic thread. The echo of their farewell is the gentle instruction: be patient, be wise, and know when to let go. And so, we bring our long, quiet journey to a close, letting the long shadow of the Atlas finally recede into the velvet dark. We have traveled through 1 billion years of geological time, faced the silent poison of oxygen, and followed a single photon's push across the interstellar gulf. The story of our ancestors, the first engineers, is one of quiet humor and profound grace. They realized that their ancestors survived a primordial soup that might kill you, and that their ultimate act of survival was simply a perfectly executed packing trip. We are left with a legacy, a gentle set of instructions. The archive waits in the deep cold, the ark sails on in the black, and the earth continues its slow, magnificent turn. We are the inheritors of a beautiful problem, a successor species being quietly judged by the geometry of a single, departing ship. The true final frontier is not to conquer space, but to master the patience and humility that allowed them to leave. History bends, but never breaks. It simply waits for the next act. Sleep now, and dream of the light that pushes us ever onward.